Hello students, in today's class we'll see standard problem, which is a very important problem, and this problem is also considered as a standard formula also. What is that? We'll see. Obtain the z transform of cos n theta and sin n theta, hence deduce z transform of the following. That first one is k raised to n of cos n theta, k raised to n of sin n theta, then e raised to minus an into cos n theta and e raised to minus an into sin n theta. So third result, and this is fourth result. So one of the very important question, as well as I can say that this is nothing but we are finding the formula for what is z transform of cos n theta and cos of sin n theta, as well as z transform of what is k raised to n cos n theta and k raised to n of sin n theta, similarly the remaining one. So this is a problem, as well as I can say that one of the standard formula. So we'll see this how to solve or how to prove this one. So solution. So we'll start one by one. We know that e raised to I times n theta, according to the complex number, it is nothing but cos of n theta plus I times sin of n theta. So remember this, what is e raised to I n theta, which is nothing but cos of n theta plus I times sin n theta. Now this we can write it as e raised to I n theta, e raised to I times n theta can be written as e raised to I n theta can be written as what here, e raised to I theta whole raised to n. So this I have applied a exponent formula. So e raised to I n theta can be written as e raised to I theta whole raised to n, which is nothing but e raised to I theta I will consider as k and raised to n as it is, where k is equal to e raised to I theta I have considered. So what I have taken, so e raised to I n theta, so e raised to I n theta can be written as e raised to I theta whole raised to n. So this e raised to I theta I have considered as k, which is nothing but k raised to n. So I can write only simply kn also. So this is one of the basic we required to prove. Already we have the standard result, that is z transform of k raised to n is nothing but it is z divided by z minus k. This result also we know it. So under these all results, that is e raised to I n theta and e raised to I n theta can be written as kn, and all can be what here simplify, and using this formula we can simplify this standard problem now. So let's start with the main requirement. Now so here we know that k raised to n is nothing but e raised to I n theta, so I will apply here. So therefore z transform of, so k raised to n is we have considered what here, it is e raised to I n theta. So I'll write e raised to I n theta is equal to, wherever k is there we'll replace this. So what happens here, so what z divided by z minus the value of k, Value of k is nothing but what here? E raised to I theta. Kn is e raised to I n theta, but k value is what here? Only e raised to I theta. I have applied here. So once we got this, so to simplify this right hand side, we have to rationalize this. What here? It will be z minus, so I will rationalize e raised to I theta, that is e raised to minus I theta divided by z divided by e raised to minus I theta. So we'll take the rationalization but not by separation of this. So here I theta is there, e raised to, will take e raised to minus I theta, e raised to minus I theta to simplify in easiest way. Now this we can write it as multiply z into z minus e raised to minus I theta divided by, these are not same because here e raised to I theta and we have e raised to minus I theta, and divided by z minus e raised to I theta into z minus e raised to minus I theta. Now we'll multiply this z to this entire bracket, as well as we'll open these two brackets and we'll see that is nothing but z transform of e raised to I n theta is equal to, if you open the bracket, z into z will become out here. First we'll inside term will simplify, z into z minus e raised to minus I theta is going to write it as, so minus sign is there, I will put a bracket, it will be cos of theta minus, because of this minus I, it will become minus, if it is plus I, it will become plus, so minus I theta is there, so minus I times sine of theta divided by, here we will open the bracket first, z into z is z square, z into minus times e raised to minus I theta will become out here minus z e raised to minus I theta, then minus times e raised to I theta into z is out here minus z times e raised to I theta, minus minus is plus e raised to I theta into e raised to minus I theta. So this is the simplification of our denominator. So again on more simplification, which is nothing but z transform of e raised to I n theta is equal to, now open the bracket, z into, if you bottom bracket, z minus cos theta minus minus plus I times sine theta, denominator z square. So among these what we'll do here, so you just concentrate for these two terms, among these we'll take minus sign common and z common, so what we'll get here, e raised to I theta plus e raised to minus I theta will get. So among this we'll take minus and z common, we'll get e raised to I theta plus e raised to minus I theta plus e raised to I theta into e raised to minus I theta. Bases are same. If you add the powers, I theta plus I theta minus I theta cancels, e raised to 0, e raised to 0 is 1. So we got this situation now. So among the numerator, so I will make this is a real part and this is the imaginary part. So on simplification further, so numerator we can't, will keep as it is, that is z into z minus cos theta plus I times sine theta divided by z square minus z into e raised to I theta plus e raised to minus I theta. We know that it is 2 times cos theta. And the Laplace transform in the Fourier transform we have seen e raised to I theta plus e raised to minus I theta plus sign comes, means 2 cos theta will come. If it is minus sign, so we'll get what here, 2I sin theta. So hope you have remembered this results. So I'm applying directly, so plus 1 as it is, so which is nothing but finally. So therefore we know that e raised to I n theta is nothing but, because already we have seen in the beginning, e raised to I n theta is something of cos n theta plus I times sin n theta, that I will enter here. So z transform of, instead of writing e raised to I n theta, I will write what here, it is cos of n theta plus I times sin of n theta is equal to the right hand side as it is. So right hand side what we have, you will write as it is, z of z minus cos theta plus I times sin theta whole divided by z square minus z into 2, I will write what here, 2z cos theta plus 1. So this is the simplified form, we got it now here. Or this we can z of cos n theta plus I times z, so we can apply linear property. So left hand side, on applying linear property on left hand side, we'll get what here, z of cos of n theta plus I times z of sin n theta. So this z of cos n theta plus I times sin n theta can be done out here, z of cos n theta plus z of sin n theta is equal to right hand side also we can separate the real and imaginary part, that is nothing but z, you multiply z into the real part, so this is the real part and this is the imaginary part, z into z minus cos theta divided by z square minus 2z cos theta plus 1, and with this plus sign plus I times z into sin theta, z into sin theta divided by z square minus 2z cos theta plus 1. So this is one of the standard situation, I can say, to simplify the conclusion. So left hand side also we have real part and imaginary part, real part, imaginary part, real part, real part, imaginary part, imaginary part. So now on equating the real and imaginary part, real and imaginary parts, we get, on equating real and imaginary part, we get real with real. So therefore real part is what here, z of cos of n theta is equal to, real part of right hand side is what here, z into z minus cos theta whole divided by z square minus 2z cos theta plus 1. So this is our first result, that is z transform of cos n theta. Similarly on equating imaginary part, we will get z transform of z of sin n theta is equal to, imaginary part on right hand side is what here, z sin theta divided by z square minus 2z cos theta plus 1. So this is the second result, that is nothing but Z transform of sine and theta. So usually we'll get both the result from the same simplification, but if you equate real part, we'll get cos Z transform of cos and theta, and if you equate imaginary part, we'll get what here, sine of n theta. So these are the two results we got it from our given e raised to I n theta, and these results are nothing but what here, using imaginary or complex situation we got it under the standard formula of our Z transform, that is Z transform of k raised to n. We have taken and we have proved this result. So by using this, we'll go for the deduction parts now. So we'll see the deduction part, but remember, what is Z transform of cos n theta? It is Z into Z minus cos theta divided by Z square minus 2Z cos theta plus 1, and Z transform of sin n theta will be Z into sin theta divided by Z square minus 2Z cos theta plus 1. Denominators are same for both, but only the new change in the numerator. So this is a problem as well as a formula for Z transform of cos n theta and Z transform of sin n theta. So let's see the deduction part. So the deduction part, so already we have the formula Z transform of cos n theta is nothing but what here, Z into Z minus cos theta divided by Z square minus 2Z cos theta plus 1, and Z transform of sin n theta is what here, Z sin theta divided by Z square minus 2Z cos theta plus 1. So under this formulas, we'll go for the first deduction. So now, so Z transform of, we need to find k raised to n into cos n theta. So this is nothing but a damping property. So in the above situation, that is, alright, Z of Z minus cos theta whole divided by Z square minus 2Z cos theta plus 1, and replace what here, Z by Z upon k. So what happens if you replace it? So it will become, Z will be replaced by what here, Z by k, that is Z upon k into Z upon k minus cos of theta, denominator Z upon k whole square minus 2 into Z upon k into cos theta plus 1. So on simplification, you can just see here, so I will not elaborate. So on taking LCM, so what we'll get here, we'll get is this will be Z upon k. If you take LCM here, it will be Z minus k cos theta whole divided by k, and this k will become k square. So if you open this, so it will become Z square upon k square. So if you take the LCM here also, it will become Z square plus, so we'll write that step. So Z, I'll write as it is. Why? Because I will tell you. So if you take LCM here, it will become what here, Z minus k cos theta whole divided by, we have k, and divided by k, what we have, I will multiply here, it will become k square. Okay, then here if you open and take the LCM, so LCM is k square, so here it will be Z square minus, here divided by k is there, 1k cancels, means it will become 2kz cos theta plus k square. This k square cancels, so we'll get finally as z transform of k raised to n cos n theta will be z into z minus k cos theta whole divided by z square minus 2kz cos theta plus k square. So this is the first deduction what they have given in the question. Now second deduction, will use the second result, that is z transform of k raised to n into sine n theta, which is nothing but we know k raised to n sine n theta is nothing but it is z divided by sine theta divided by z square minus 2z cos theta plus 1, and using the damping rule, so z will be replaced by what here, z upon k. So on replacement we'll get the result as here also, so I am writing directly, so it will become kz sine theta whole divided by z square minus 2kz cos theta plus k square. So this is our second deduction, that is z transform of k raised to n sine n theta is nothing but kz of sine theta into divided by z square minus 2kz cos theta plus k square. So similarly the two more deductions. So next third one. To get third one, what we'll do here, by taking k is equal to e raised to minus a in result 1, that is deduction 1. In deduction 1, if you replace k is equal to minus a, so what is the deduction 1, we'll see now. So this is our deduction number 1, that is z transform k raised to n cos n theta is equal to z into z minus k cos theta whole divided by z square minus 2kz cos theta plus k square. So this is the deduction 1. So here we need to replace k is equal to e raised to minus a. Wherever we have a k will replace. So this k will become out e raised to minus a raised to n, it will become e raised to minus a n. And wherever k is there, replace e raised to minus a, will get the result number 3. We'll see that what. So it will be z transform of e raised to minus a n cos n theta is equal to, we are replacing k by e raised to minus a, so we'll get z minus e raised to minus a cos theta divided by z square minus 2 e raised to minus a z cos theta plus we have k square, instead of k square it will become e raised to minus 2a. So this is a result number 3 or deduction number 3. And deduction number 4, again here also by taking k is equal to e raised to minus a in deduction 2, we'll get what here, z transform of e raised to minus a n sine n theta is equal to e raised to minus a z sine theta divided by z square minus 2 e raised to minus a z cos theta plus e raised to minus 2a. So this is a deduction number 4. So in this way we need to simplify this standard problem.